Okay, welcome to another video. In this video, we're going to talk about the systems of linear equation in two variables. We will talk about the three variables next time. So let's just write this thing in two variables. Okay. So we are going to look at the two methods. First one is called the elimination method. And the second one is what we call substitution method. Now, either method is going to be okay, but there will be a time that you would prefer the using one method over the other because of the nature of the equation is written. So one method is going to be much easier to apply than the other methods. Okay, so let's just go through these methods here, and then we'll look at some applications for these two types of methods here. Now, as I said, you can use either one, okay? But I'm going to show you two different ways of doing two different ways for elimination and substitution method here. So first, we're going to look at the elimination method. So let's say we have something like this. Okay, we got 5x plus 2y equals to minus 5. And the other is minus 2x minus 4y equals to minus 14. So elimination method, we are using elimination method here. So elimination method is that we want to eliminate either x or y, so we can have the unknown variable by itself, just one. Okay. So we want to find out what do we have to do to eliminate x or y. It doesn't matter which one, but one of them has to go. Okay. So I'm looking at these two x and y variables here. So if I multiply the y by 2, I get 4y. So 4y minus 4y, then they go 0. So maybe that's what I should do, right? So what we're going to do here is that we are going to multiply the first row. You're going to have to do this entire row. So you got 5x plus 2y equals to minus 5. We're going to multiply entire row by 2. Why? Because 2 times 2 gives you 4y, and 4y minus 4y, you get 0. The second row is not going to change. It's just going to stay as it is. Okay, so there you go. Now let's multiply these out, see what we got in the first row here. So 2 times 5x, we get 10x. 2 times 2y, we got 4y. And 2 times minus 5, we get minus 10. And the second row stays the same. Oops. Minus 14. So now we're going to add these two. Okay, so if I add these two, then 4y minus 4y, they cancels out. And then 10x minus 2x, I get 8x. So I no longer have a y here, right? And then minus 10 minus 14, I get minus 24. And then we're going to divide it by 3. And x becomes, oops, okay, x equals 2 minus 8. That's kind of nice, right? And then all you have to do is find the y, but you can plug in x values to either one. So I'm going to do that on the first row. So then you got 5 times x, which is a negative 8, plus 2y equals to minus 5. So you got minus 40 plus 2y equals to minus 5. Okay. Now then we are going to, let's see, did I mess up here somewhere? 24. Oh, we're going to have to divide, I'm sorry, you're going to have to divide, I'm going to have to come back here. We're going to divide it by 8. Sorry about that. So, divided by 8, not 3. I don't know why I say 3. Let me get here again. So that should be 8. And then, this x value becomes what? Negative 3. Sorry about that. So here, instead of 8, we're going to have to plug in negative 3. Okay, so, go back here. So that should give us the minus 15. Okay, sorry about that. Now, we're going to solve for y, so we're going to add 15 on both sides. So 2y equals to 10. If you divide by 2 on both sides, we get y equals to 5. Okay? So in this case, the solution is going to be x equals to minus 3 and y equals to 5. So that's how the elimination method works. And so you want to look at each row of the equation and find out, well, which variable can I eliminate? What do I have to do? So, so you just want to find out the variable that you want to eliminate, and then try to rewrite the one or the other so that when they add up, they will be eliminated. Okay? So the basic idea of elimination method there. Okay? Now, we are going to, let's look at another example here. So just make sure that everyone understands. So I am going to use another one. Okay? And then we'll go on to the substitution method there. Hang on a second. I'm just trying to pick another one for you. I have, let's see, okay, here's another one. So I have x plus y equals to minus 5. Yes. Okay, and the second equation is minus x, okay, and the plus 2y equals 14. So in this case, it's nice because the x and minus x, if I just add these two, they go away, right? So let's just add these two rows. So then x minus x is going to be equal to 0. Now y plus 2y, now you get 3y. And minus 5, 14, you get positive 9. So now y becomes a 3. And if I plug this back into the first equation, let's do that. So if I have x plus 3 equals to minus 5, and if you subtract 3 on both sides here, then x becomes minus 8. Okay, so in this case, the answer is going to be minus 8 and 3. So that's nice, right? Now let's look at the substitution method this time. Okay. Now I'm going to use the same problem. Here the x plus y equals to minus 5. And minus x plus 2y equals to 14. So if you want to use the substitution method, you're going to have to write one term or one variable in terms of the other one. Okay? So what I am going to do here is that, I'm going to look at the first term over here, the first equation. Okay? And I'm going to rewrite that so I can make a substitution. So let's just do that. I'm going to subtract y on both sides. So then you got x equals 2 minus y and minus 5. I subtract y from both sides. So when you look at the second equation, we are going to substitute x with minus y minus 5. So let's just plug that in there. So minus y minus 5 plus 2y equals to 14. Now let's apply the minus here, so that you're going to get what? Y plus 5 plus 2y equals to 14. So y plus 2y, you get 3y plus y equals to 14. Subtracting 5 from both sides. And then we get 3y equals to 9, and the y equals to 3. And that's what we got over here when we use the elimination method, right? So once you find the 3, then plug back into the first equation or second equation, doesn't matter. So you got x plus 3 equals to minus 5. So subtracting 3, we get x equals 2 and minus 8, and that's what we got using elimination method. So it depends on the equations that you have, whether you want to use the elimination method or substitution method. But regardless of which method that you are going to use, you should get the same answer there. Let's try another one using the substitution method. Okay, so let's try the 5 over 2x, okay, plus 2y equals to 5, and 3/2x plus 3/2y equals to 9/4. Okay. You can use either method here, so why don't we just, we're going to rewrite over here. Why don't we rewrite this? So I'm going to subtract 5 over 2x on both sides. So you're going to have what? 2y is equal to 5 minus 5 over 2x. Okay. I'm going to isolate the y by dividing everything by 2. And this one I'm just going to multiply by 1/2. So that means y equals to y over 2 minus 5 over 4x. Okay, it's going to get a little bit messy, but we're still okay. So what we're going to do is that we are going to replace this y over here with this guy here, 5 over 2, okay, 5 over 2 minus 5 over 4x. That's what we're going to do, okay. The one thing that we're going to have to be careful here is that we're going to have to multiply the entire y that you are going to substitute with the 3/2 in the front. Okay, so you're going to have to be careful about doing that. It's going to be a multiplication of the fraction, so let's be just careful when you do that. So we are going to, maybe I should use this one. So we are going to multiply that out. So I still have a 3/2x on the first one. On the second one, we are going to replace y in terms of x. So I have what? 5 over 2 minus 5 over 4x equals 2 and 9 over 4. So as you can see that we no longer have y there. Okay? So we're going to have to be multiplying this out, but that's okay. We are going to do this one at a time here. Okay, so the inside, we got 3/2x outside over here. Now we're going to multiply these out, okay, here and over there. So we got 15 over 4 minus, we got 15 over 8x equals to 9 over 4. Okay, so I am going to subtract minus 15 over 4 on both sides. Okay, and I'm going to rewrite it. I have 3/2x minus 15 over 8x equals to 9 over 4 minus 15 over 4. Okay. Yeah, bring this up a little bit. Okay. So we're going to combine the terms on the left and right side here. So if I combine these two, the common denominator is going to be 8. So I'm going to multiply the first one by 4 at the bottom, and I'm going to do the same thing on top. So that means I have 12 over 8x minus 15 over 8x. Here we already have a common denominator, so we're just going to subtract 9 minus 15. There will be a minus 6 over 4. So on the left-hand side, 12 minus 15, you got minus 3 over 8x. Then you got minus 6 over 4. So we are going to isolate the x by multiplying its reciprocal. So minus 8 over 3. And the minus 8 over 3. So on the left-hand side, I have x. On the right-hand side, we are going to have to do some housekeeping here. So 4 goes into 8, that's going to be 2. And 3 and the minus 6 is also 2. But they are both minus. Okay? So you got minus 2 times minus 2. Okay, the answer is going to be positive 4. Okay, so x is going to be equal to 4. And you can plug that into the first equation, and then we'll find out what the y is. Okay, so x equals to 4. Now let's plug that in. So you got 5 over 2 times 4 plus 2y equals to 5. So as you can see that 2 and 4 cancels out, giving us the 2 on the top. So you got 10 plus 2y equals to 5. Then we are going to subtract 10 on both sides. Okay? And what we have here is the 2y equals to minus 5. And then we're going to divide it by 2 on both sides. So then y equals to minus 5 over 2. Okay? So your answer is going to be 4n minus 5 over 2. So you're going to, it depends on the, the equations you have. You might want to choose one method over the other one. But I don't have any preference unless I ask you to do it, either method. But mostly it's going to be up to you. Whichever the method that you prefer, you're going to use that. Now, whenever we solve the system of linear equation, it doesn't matter if you have 2 variables or 3 variables, how many variables you have. You're always going to end up with one of these 3 solutions here. Okay? So here's the 3 types of solution. Okay, for system of linear equations. Okay, so the first type here is that you just like the problem that we did. The 3-4 problems that we did previously. You're gonna get the the one equation going this way and the other one is going this way. So you're going to get a one solution. Okay? And that's the problems that we did so far. So you do have a solution, one solution. Okay? So when you have a solution, okay, if a solution or solutions exist, okay, we call consistent. Okay, and if graphs are different, okay, we call independent. Okay, so consistency and the independence. There's going to be the 2 things that we're going to have to remember when we solve these different, kinds of a system of linear equations. So if you have a solution, then we have a consistent system. If the graphs are different, then we call that independent. So that's the first one solution. Okay. Now, second type here is that you have equation. The equations, but they are parallel. Okay, these are parallel. So this means that not, these two lines are not crossing one another. So this means no solution. Okay, unless you cross one another, you're not going to have any solutions, right? So in this case, you don't have a solution. So that means that we don't have a solution, then inconsistent. Okay, because no solution, inconsistent system. And indeed, the graph's going to be different, right? So graphs are different. So this is the, no solution. Oh, let me just do this here. Inconsistent system because no solution. Let me just do that. Because no solution. And then we have independent because graphs are different. Okay? So that's going to be the second type of a solution. Now the third one is going to be that when you have these two graphs, they are identical. Okay? So in other words, that one graph is on top of the other one. Okay. Now we draw this one. So one graph is going that, and then the other graph is going to be on top of the other one. So like this. Okay. So in this case, we have many solutions. I can say infinite number of solutions, right? So we know that because we have a consistent system, because, right, many solutions. But they are dependent. Okay, because graphs are same. Okay? So whenever you solve this system of linear equation, it doesn't matter whether it's going to be 2 variables or 3 variables, or it doesn't matter. It has to be fall into one of these 3 categories. Okay? So we already saw the one solution because the example that I shown you was the according to the case number 1, first type. So I'm going to show you the other 2 types in examples and make sure that you guys understand what I'm talking about here. So here, this is going to be the type 2 with no solution here. So I'm going to give you an example. So here's the 3x plus 2y equals to 2. Okay. And I have a minus 6x minus 4y equals to 8. So I'm going to use the elimination method, and I'm going to multiply the top by 2. So here's what I'm going to do. 3x plus 2y equals to 2. And then I'm going to multiply this by 2. And I'm not doing anything on the second row here. I'm just going to rewrite it. Alright, let's multiply this out, see what we get. You got 2 times 3x, you get 6x. Plus 2 times 2y, we get 4y. And 2 times 2, you get 4. And then the second equation, we got minus 6x minus 4y equals to 8. Now we are going to add these two. So you notice though, you get minus 6x minus 6x go away, 4y minus 4y go away, and 0 plus 0, you get 0. On the right hand side, 4 plus 8, you get 12. But this is false. Why? 0 cannot be equal to 12. So this one has no solution. Right? And that's the second case over there. So if I draw this on xy plane, the graph will look like this. One going this direction and one going this direction. So this one is the minus 6x minus 4y equals to 8. The one on the top is 3x plus 2y equals to 2. Okay, so this is the case number 2, where two equations are parallel to one another. Now let's look at the third case with the many solutions. Okay, something like that. This one I have 3x plus y equals to 1 and minus 6x minus 2y equals to negative 2. Again, I am going to multiply the top by 2, okay, and then I'm going to add. So I have 3x plus y equals to 1, and minus 6x minus 2y equals to minus 2. To multiply that out, I have a 6x plus 2y equals to 2. Then I have a minus 6x minus 2y equals to minus 2. Now we add. So then we have a 0 equals to 0. That's true. Okay, so in this case, we're going to have many solutions. Now, you guys need to understand that because I have a 0 equal to 0 doesn't mean that, solution doesn't exist. It is the only time that where the left is not equal to the right, then you don't have solution. But if it's going to be like 0 equal to 0, like 10 equals to 10, it's just saying that you got many solutions there. So if I draw these two lines here, you will get something like this graph. But they are both of them on top of one another. Okay. So that would be the third case here. So you're going to have to be, you don't have to worry about writing this and using notations, but you're going to have to realize that when you solve the system of a linear equation, you have to be getting the answer in one of these three cases. Okay, and you can actually tell by looking at the graph, but you actually have to solve it algebraically and then see what the results are, and then you can determine by the xy value that you found, or the case that left is equal to right or left is not equal to right. Okay, so that will determine whether you have no solution or the many solutions. So we talked about the two different methods of solving system of a linear equation in two variables. And when you solve those system of linear equations, so your solution has to be one of these three categories, right? One solution, no solution, many solutions. Alright, using this idea now, then we're going to attack the word problem. Okay, so I'm just going to give you guys some idea. We are going to look at the mixing problem here. There are some number problems there, but they are too easy, so I'm not going to do them. But I am going to do the the mixing problems, so you guys can see the applications of systems of linear equations. Okay. I guess we can do. Let me see. Well, let me do this. I'll do one each. So here's the one problem. I'm going to write it. Okay. So let's say the sum of twice, and sum over twice a first number, okay, and 3 times, okay, a second number. Extend this a little bit here. Second number is 81. Okay. If the second number, if the second number is subtracted, from 3 times the first number, the result is 17. Okay, find the numbers. Okay, so let's take a look. So before we actually solve anything, okay, we're going to have to write the system of linear equation here. Okay. So we need to look at the first part here. I'm going to highlight this one first. It says the sum of the twice a first number. Oh, that's not ABD, right? Yes, we can. And the 3 times the second number is 81. So why don't we just write that? Okay. So let's just write that. So let's just call the x equals to first number. And the second number, we're going to call it y. So sum means the add. I'm just going to put the plus sign in between. So sum of twice of the first number. So that means a 2x. And the 3 times the second number. So 3 times the second number is 81. So we wrote the first one. Now, if the second number is subtracted from 3 times the first number, now remember we have subtraction here. So second number, remember the second number is y. So second number is subtracted from 3 times the first number. 3 times the first number, okay, then it's going to be equal to 17. Okay. So that's going to be our number here, set up. Okay. So we're going to find out what number we have here. Okay. So I'm going to use the elimination method by multiplying the bottom one by 3. So we can eliminate the y here. So we're going to have the same thing on the top, 2x plus 3y equals to 81. And then we are going to multiply the bottom equation by 2. Okay. So use that. So then you got 3x minus y equals to 17. All right, let's do that. So we have what? 2x. I'm talking about 3, not 2. We have to multiply this by 3, right? Because 3 times minus y, you got minus 3y. So let's do that. It's going to come down a little bit here. So I have a 2x plus a 3y equals to 81. Then I have a 9x minus 3y equals to what? 51. Now we're going to add this. So as you can see that 3y minus 3y, that cancels out. It gives us the 11x equals to 122, right? Or 132, I'm sorry. Okay. 132. So we are going to divide by, hang on. So let's find out what we have here. So 132 divided by 11, we get 12. We're going to divide both sides by 11 here. And x happens to be 12. So that's going to be our first number. Right, first number is a 12. Now we're going to have to plug back into one of these to find the second number. Second number is y. So why don't we just use the second equation there? So you got 3 times 12 minus y equals to 17. So 36 minus y equals to 17. Subtract 36 from both sides. Okay, so minus y equals to minus 19. So y has to be 19, and that's going to be our second number. Okay, so the answer should be 12 and 19. Okay, so you guys need to understand how to translate the given situation into systems of linear equations. Okay. Now let me give you the next one is a mixing problem here. So I'm going to show you here. Okay, so let's see. This is more of a mixing problem here. So let's do that. All right. So the second problem, I'm going to type it here. A coffee shop manager, okay, wishes to form a new brand, okay, of coffee. She wants to mix Sumatra beans that sells for $12 per pound. Okay. With Brazilian, beans, that sell for $8 per pound. Okay. To get 50 pounds. Okay. Of the new blend. Alright. The new blend will sell for $9 per pound. Okay. How many pounds? Okay. Of the Sumatra. Okay. And the Brazilian beans are required. Okay, so I'm going to move this up a little bit here. Alright. So I think we did a similar problem, I think week 1 or 2. But at the time, we wrote one coffee in terms of the other coffee. Okay, but this one we are going to use the system of linear equations. Again, I am going to use the circle, like so. That was not good. Okay, so let me just draw the circle over here. Better. And the plus, okay, equals to, alright. So here's what we're going to do now, okay? So we know the quantities and some of the information that we got. We know the quantity and the price. So if you look at the Sumatra, and this is going to be a Brazilian, and this is going to be a new brand. Okay. So what we have here is that we need to know the quantity. Okay, so let's just call the Sumatra X, and the Brazilian is going to be the Y. Okay, so I'm going to write the quantity at the bottom. So whatever the quantity I have, X, and the Brazilian I have, the total is going to be 50 pounds. So that's what it says, right? This is going to be get 50 pounds. So I'm going to write 50 pounds. Now the Sumatra is selling it for $12 per pound. Okay, so I'm going to put the prices on top. $12 per pound. And the Brazilian is going to be $8 per pound. Okay. And what we want to know here is we are going to sell this one at $9 per pound. Okay, so let me write that here. We want to be selling it for $9 per pound. So that's going to be the setup here. So we're going to have two different equations. One is for the quantity. The other one is going to be for the price. Okay, so let me just write that for price and the quantity. So price is going to be one on the top. So remember the Sumatra is X and Brazilian is Y. So for the price, we have what? 12X plus 8Y is going to be the $9 per pound we're going to have a 50 pounds, right? So that's going to be 450. But quantity is going to be simply x plus y equals to 50 pounds. Now you have to be careful on this guy here, because how do you get 450? Well, if you're going to make a 50 pounds and you're going to sell it for $9 per pound, then it's going to be $450 there. So that's what the price is. Quantity, we're just going to have to add, right? Because we don't know what the quantity is for Sumatra and Brazilian, but they have to be added up to 50. So that's what the equation is. Now, in this case, it's going to be pretty simple, right? Because we're going to have to solve this for either x or y, then we can just substitute back into the other one. So what I'm going to do here is that I am going to multiply the bottom one by -8, so I can eliminate the y variable. So now I'm going to write it 12x plus 8y equals to 450. Now we're going to multiply by -8 on the second equation here. Then x plus y equals to 50. Okay, so if I do this, I have what? 12x plus 8y equals to 450. I have a -8x minus 8y equals to -400. Okay, so now if I add these two, you can see that y they are canceling out. So 12x minus 8x, I get 4x, right? And then I have a 50. 450 minus, okay? So that means, okay, we're going to have x is going to be divided by 4. I'm going to put them up here. So now the x divided both sides by 4, you get 50 over 4. So that's what? 12.5. So now it'll be 12.5 pounds. So Sumatra, you have to have a 12.5 pounds. So this is going to be a Sumatra blend. Now we need to find the Brazilian, right? But we know that we can use the x plus y equals to 50. So let's plug that in. So x equals 12.5, so 12.5 plus y equals to 50. So y equals to 50 minus 12.5, and y is going to be what? 37.5, and this is going to be our Brazilian blend. Okay, so we're going to be needing 12.5 pounds of Sumatra bean and 37.5 pounds. I forgot to write pounds here of the Brazilian blend. Okay, so if you plug those in, you get 50 pounds, right? So that's what we're going to do when you have the mixing problems. So mixing problems, you're always going to end up with the two equations. Usually the one equation is for the quantity, just the adding quantity, and the other equation is going to be expressing the price with the quantity. Okay, so that's going to be the one thing that we're going to have to look at. All right. So next video, I'm going to talk about the techniques, different techniques that we need to solve for having 3 different variables here. Now, we are not going to use the substituting method for the 3 variables. We're going to use Gaussian eliminations and the the row echelon form, and we're going to use the matrices to solve the system. Okay, and the it's going to be a little bit involved when we have 3 variables, and the I would try to explain as clear as I can, but you're going to have to follow step by step, so you might need to watch a video more than once to understand what's going on. Okay, so that would be the next video. I am going to send you guys the email about what's happening this Wednesday and next week. All right, I'll see you next time. Bye bye.